Okay, so we're now going to move on to me showing you how you create your own Docker file, which will allow you to build your own Docker image. So we're going to write a Docker file to create a Docker image that will contain a number of files that I have created, which are currently stored in the directory script data Docker demo. So if we just go into that directory, you can take, by the way, obviously, any directory that you want on your own machine. You see we've got a folder called data, which contains my underscore data CSV, a folder called script, which contains plotmydata.r, and then just a .rproj file. So what we need to do is write a Docker file, which is then used to build our Docker image. So we're going to do that, again, the terminal. We're going to use a neat little built-in text editor called Nano. So we're going to say nano Docker file, make sure you put capital D. We're going to write a Docker file that will build a Docker image based on Rockerverse, our version 4.1.1, and we're going to add to the Docker image that we're building the files and directories in the directory that we're currently in, so the data file and the RScript file. So we're going to start with building from Rockerverse, RStudio. Let's type it correctly, Studio. And it's going to be 4.1.1. You can build based on any version of R, whatever you want. From Rockerverse version 4.1.1. And we're going to add to our Docker image the data directory, which contains the file mydata.csv that we just looked at. And we're going to create it in our Docker image in the data folder in RStudio. We're also going to add the script from the script directory, the plot my data script. We're going to put that into the RStudio script folder. And we're also going to add the .rproj file, just as keeps things organized. Docker demo.rproj, and we're just going to add that to the RStudio folder in our Docker image. Okay, so that's all we need to do to build our Docker file. So we're going to save it. Press Control X, save modified buffer. Yes, we want to save it. We want to save it as Docker file. Okay, so if we now list the files we've got, we see we've got Docker file. If we just want to inspect the contents of Docker file, we can use the cat command, cat Docker file, and that will basically print out in the terminal the contents of that Docker file. Okay, I'm also going to create a Docker ignore file, because I kind of don't really want the actual Docker file being contained within the Docker container. Seems a little redundant. So I'm going to create Docker ignore. So it's a separate file. And within that, I've already created it, I've seen. We've got the Docker file, and we're also going to ignore this file. Okay. So we've now got everything that we need in order for Docker to build the image that we want it to, which will contain Rockerverse 4.1.1 plus our RScript and our data file. So we can type docker build, and we're going to call it my our demo image, and we're going to build it with everything in the current directory. So if we press return, it's now going to build that image from following that Docker file that we created. It's going to use the commands in that, and it's going to build the image using the various layers that we've asked it to. So you can kind of get an update on the build here. You can see actually it's going to be putting quite a lot of data in, so it'll probably take maybe 5 or 10 minutes to actually build the image because it's pulling in any layers that it doesn't currently have. So I will probably speed up this video so that you're not having to sit here watching my screen for the next 10 minutes or so. So I'll edit this out. Okay, so we're basically almost there at this point. It took maybe a little bit longer than I might have expected. I think it was about 10 minutes or so because of the number of Docker image layers that it had to pull from Docker Hub, but it's just finishing off now with I think extracting the final layers. We've built this new Docker image using our Docker file. It's a combination of Rockerverse 4.1.1 plus the R script and the data file that we stored in our local machine. So it's just doing the finishing touches here. Once it's downloaded, or rather once it's downloaded the images and built our new Docker image, we'll have a little look to see what images we have on our computer, and you'll be able to see that we've got the our demo image now installed, which we've just built. So you see up here, timer ticking away. We're on build stage 6 out of 10. It's just extracting, I think, the final layer, so it should be done pretty quickly once that final extraction has taken place. It does take a fair bit of bandwidth to download these various Docker images. So if you're on a capped broadband connection, just be careful you don't exceed your data quota. And there we go. So it's done all the stages now. It's built our new Docker image. If we type Docker images, we get our demo image built 10 seconds ago, 3.75 gigabytes. So, pretty large file. So we've built this new Docker image, and to get it up and running, we do it as we have done things previously. Docker run --rm, set our port to be 8787, I've done to 8787. We're going to mount the volume, RStudio. Going to set our password variable just to be the word password, and it's going to be my R demo image return. So that's going to start our Docker container. Just ignore that's not an error per se. That is actually, tell you what, there's a typo in my Docker command. So let's just quit that. I wrote password minus password. Should be password is equal to password. Let's just run that again. So it's got the Docker container up and running, and we can access as per usual, going into our web browser, firing it up, Studio. And what we'll see when it starts is R 4.1.1 plus the data directory and script directory that were exactly as basically we asked for it to be built in the Docker container. We can just run it if we want to run tidyverse, read in the data. The data is read in from the data directory, my underscore data.csv, and then we can just do the plot. So again, we're just running everything in our Docker container. It's nothing to do with the version of R or RStudio or anything to do with what's on our computer itself. It's all self-contained in the Docker container, including the script and the data file. So we can kind of run everything like that. And if you wanted to, you could also connect it to a different local directory on your machine. So if you wanted to be able then to write to another directory, you could do that. So we'll quickly do that now. Actually, we'll close down this Docker container. I will navigate using in the terminal to a different folder. Let's go back into the UFO one actually. And let's relaunch our Docker container, but this time let's launch it so that the working directory that we're currently in, which is the UFO working directory, gets mapped onto a new folder in our Docker container that I'm going to call local. So we just do it as we did previously. Run the docker run command. The container is running. Let's access it on our web browser. And when we see our container now running, you'll see that we can also access via the local directory our local machine. So we can actually write here. So if we wanted to, sort of write a script, analyzing, manipulating the data that's under a Docker container, and then write it locally, we could actually write it to this directory here using write_csv, and then writing locally. So I think that's a great example of how you can, share a Docker image with a particular configuration of R in RStudio, maybe with your data in it, with people that you're collaborating with. So everybody is effectively working with the same version of your experimental data, but also with the same package versions and everything else that you're working with. And if we wanted to, we could then just upload our new Docker image to Docker Hub. And there are instructions on how to do that in the lecture slides, by the way. I'm not going to sort of go through that here. So hopefully you've been okay sort of building, writing a Docker file to build a new Docker image. You can kind of see how then you can link that Docker image with a directory on your local computer. Also in the lecture slides, I sort of give a demonstration about how you would do this in Python. Same idea, you build a Docker file. In addition, in Python, you need an environment YAML file, which will contain information about the Conda environment that you want to be running within your container. But the instructions for doing that are all in the lecture slides. So it might be an idea for you actually to try and do that yourselves. But hopefully, I've convinced you that Docker is a super useful tool. It's pretty much the only way to do fully open, fully reproducible research. It allows you to build these Docker containers, or build these Docker images rather, to run Docker containers that you can then share with others. And really this has become the go-to way of building images and running containers. There are other solutions other than Docker around, but Docker's really kind of become the most commonly used. So that was just a very broad but hopefully reasonably detailed introduction into the wonderful world of Docker.